So, welcome back, everybody, on this, the day of Delilah's birth. What do we have to say? We'll just do it normal. Happy birthday.
Happy birthday to you. Happy birthday, dear Lila. Happy birthday to you.
Yes. Now, Delilah, I want you to make sure that when you hear this, you check your email, because in your inbox from me, you will have a wonderful link to register yourself to vote. Awesome. So, let's get rolling. What's d squared s of t dt squared? It's acceleration. Now, there's a few different ways, and I'm okay if we just write acceleration here. It doesn't bother me, but I do want to make sure that we're comfortable with this is the same thing, and I'm going to write this one in pink. I'm okay with this. Could we have also said this is just dv of t dt? It's a derivative of the velocity. These are the same thing. And this lovely expression right here, a of t, is short for acceleration. I'm going to make it a capital A. For some reason, I didn't. And what is the SI for acceleration? Meters per second squared. Now, that's always a weird one. And in physics, I'm going to be honest, the hardest part of physics for me personally is the units, because you have to remember them, you have to keep them straight. The other way that we think about this is meters per second. How much does a meter per second, the velocity, change per second? Which you could have meters per second if you want. But this is when the option of writing meters per second squared is there instead. Okay, so we have these wonderful things. Today is going to be pretty chill. We're going to do 1 or 2 application problems where we do stuff like this. And then you get a bunch of time to work, because today is the ultimate day of what? Ultimate is in the last. So it's the last day of January for us. 31st is tomorrow, right? Is January 31? There's something tricky to do with your knuckles, but I don't remember it. Okay, well, let's do an application problem. And if you didn't catch the answer to that last one, it's the ultimate day of the chapter, which means on Monday, we're going to start reviewing. But I'm going to be chill, right? We're doing the second half of the chapter. What are you doing, Sean? Well, I think it's, I don't know, something. January, February, if you hit a knuckle, it ends, right? But there's some place where you get 2 knuckles somewhere. Right? November 31 and December 31? Is that true? I don't know how many days are in the month. November's 30. There's one of them that's double, right? Anybody know what I'm talking about with the knuckles? Do you know how to do it? Is there never a repeat with 30 days or 31? I don't know. That's not calc. Let's do some calc. All right. So checking it out. Here we go. I'm going to use a little editing magic to save some time on the video. So it'll look like I just write really fast and instantly. All right. Now, we have a differential equation in front of us, and it can be hard to tell that. How do we know it's a differential equation? Or how do I know? And I hope you know. They give us velocity and they ask us to find what? The only way to go from velocity back to position is to do what? Antiderivative. So we have a derivative given, and now we need to undo that derivative. So there's a couple things that whether you physically write these down or not is entirely up to you, but especially for the first problem where we're doing application, as long as we can get everything that we have here like made sense and ordered and make it look like just a regular math problem, because it is really just a regular math problem, just hiding in here. So let's do that. First of all, do we want to stick with calling this v of t, or is there another way that we could write it since we're finding position? So I wouldn't use y. I wouldn't use d squared either, because that's a second derivative. S prime. Now, I have no preference necessarily. Are we writing s prime or ds dt? Okay, so we now know that s prime of t instead is what? 4 minus t squared. Now, if you're looking at this going, what? I'm going to make the note here that pink is for deep think or whatever, optional stuff. How would we explain what happened? Why do we do this? S prime of t is the same thing as what? Velocity. Good. Okay. So we have that part worked out. Now, when we solve for a particular solution, which is what we need to do, we want to know where is this particle at? What is the particular position of this particle at this time? So we need a very specific, like exact answer, which is our particular solution. To find the initial to find a particular solution, we need a what? It's an initial condition. Good call. What is my initial condition? 3 and 5. Now, I'm going to be very specific that where, and I'm going to go back to red, where, is that an ordered pair that you gave me? So I'm going to make the claim 3 comma 5 is on the graph, and we can say it's on the graph or it's a solution point. Either one works, but I like to think of it as on the graph of what? S. We are given the position of this thing. Now, with all of this, if we forget everything that we've written above, does this look any different than the problems we did yesterday? No. I hope not. Like, I'm given S prime and I want to get S. That's what we're after. Together, or do you guys want to anti-differentiate and solve for that constant C on your own? Some people are already kicking, so I'm going to let you guys go. I'm going to give you a head start. I will also start working it slowly, and do your best to not look up until you want to check your answer. I wish I could freeze the screen, but I can't. So we'll meet up. I'm going to give you guys a little head start, and then I'm going to start working it. In the interest of time, I'm going to pause it here. And then as I'm walking around, because I'm giving you a head start, if you have no idea what to do, who might be able to help? Me, or Miss Sweet, or Angel, or Abigail, or Bea. Like literally, I think that all of you can help each other. Honestly. Cool. Try it out. So up on the board, if you have your antiderivative, your general solution already, this is what I think we come up with. 4t minus t cubed over 3 plus c. Pending a huge mistake that I've made, but I don't see one. Sean, what's your mistake? Okay, so easy mistake to make. If we were given acceleration, we would have to, but we don't have to from here. This is my what solution at this point? General. Now, I don't really need a general solution for this problem, so we're not going to include it. How do I find C? Yeah, what do I know the position they give me is? So my position specifically is 5 meters, right? And that happens at which time? 3. So I'm just going to plug these in here, and I'm going to write it like this because I hate this color changing. 3 and 3. Cool. I see some calculators out, and I'm fine with it. I think you're going to be faster than without the calculator. Purely from a curiosity perspective, I'm going to wait until you guys are done working because I don't want to distract you as you're still going, because most of you still are, which I appreciate. So I see people grabbing for them. Pause here, because you're grabbing for your calculators, I imagine, to clean that up. I don't think you need to. I just want to show you that I think this is faster, and I'm confident that it's faster than finding your calculator, turning it on, and doing it. Do you guys know 4 times 3? 12. Now the other one, this 3 cubed over 3, you may be looking at it and go, oh, I don't really want to deal with it. 27 over 3 is how you can think about it. But is there another way that fractions or powers work? 3 to the third over 3 to the 1? They do what? Can we just say that's minus 9 then, since I know it's 3 squared? And look at this. I think it's legitimately faster than with your calculator. Now, of course, if I'm talking it, it's not quite as fast. But I think we can solve this. There's 3 over here that I'm going to subtract. What's C? So if I want to know, and let's just see what the actual thing was, find the position when t equals 4. Are we done? Not quite, but we have a what solution at this point? We have a particular solution. And I know it's this, t cubed over 3 plus 2. Everybody cool with this still? Was this what you were grabbing your calculators for, or did I just make a huge assumption? Because it might have been the next step, and I can't tell because it didn't come and like look over your shoulders. First step or the next step? Okay, so same thing. I think we're going to be doable with it. I need to find the position when? At time 4? Okay, so this position function says if you tell me what time you want a position, here it is. I just need to find S of what? One more time? 4. And I'm not going to switch colors. I was going to. But let's see. What's 4 times? And I'll actually do it here in case people are struggling. 4 times 4 minus 4 cubed over 3 plus 2. Help me out here just without a calculator just to see if we can do it. 16. What's 4 times 4? Times 4? 64 thirds plus 2. So that's 18 minus 64 thirds. If I just combine these two first. Okay. And I'm taking little steps through here because we all might do this little algebra differently. How on earth do I do this? Do 64 to the thing. I don't know what that means. How do I do this if I don't have a calculator handy? Because this doesn't have to be a calculator problem. Multiply by 3? But multiplying by 3 triples the value. You're close. I'm just being really specific with the language. I can't multiply this by 3. What do I multiply it by? 3 over 3, which I know that's what you meant. I'm certain of it. But there's a huge difference between multiplying by 3 and multiplying by, what's 3 over 3? 1. What's 18 times 3? 54 thirds is how we're thinking about this. Minus 64 thirds, I think, is negative 10 thirds. Okay, at this point, because we have a context, what should we have here? How do we express our answers? Like, this is the correct answer, technically, but why are you not going to get points? Yeah, I'm crazy about it. I try to be really crazy about it. I assure you the AP readers will be much crazier than I am. If you stop here, you're going to miss probably 2 points out of 9 if this were a free response, because we need that lovely statement. At time, what time are we checking this at? So t equals 4 seconds. What are we talking about? So the position, but we're looking for the position of a what? And we need to say the particle. We can't say it. It has to be very clear. At time, t equals 4 seconds, the particle is at, and there's a few different ways that we could word this. We can say, how would you explain this answer? You could say negative 10 thirds meters, which feels a weird way to word it, but you could. Compared with what? And that's the weird part. What do you think our initial position, we should say, like, we know the initial position was 2, right? And do we know the initial position was 2? Fern, how do, like, you were nodding, and I see other people thinking about it. I think your nod says, yeah, clearly. Why 2? Okay, so we're at negative 10 thirds meters, and this is wonky. I don't really like this language. Does it feel clunky to you right now as we're saying it? I'm at 10 thirds meters, negative 10 thirds meters. Doesn't that feel weird? Is there another way we could word this? So I'm going to do some thinking off to the side, and my hope is that there's really some yeses floating out there saying, oh, yeah, we could probably word it differently, but I'm not getting any of that from you. I'm not going to just change this to 3 1/3. Like, that's not what I'm looking for, just so you know. We started at 2, right? And we ended at negative 10 thirds. So if we think about just what's going on here, and I'm going to cross this one out, just because I think we have a much nicer way to word this. So here's where I started. I'm at 2, and now I might think in decimals for a second. I'm at negative 3.3, right? Instead of saying I end at negative 10 thirds, which is not incorrect, but it feels weird. How far am I from where I started? Like, I've been displaced. By how much? 5.3? Can we say, instead of saying we're at negative 10 thirds meters, which is true, I think it makes more sense, and it's a much more natural way to speak. We'll say is, and I'm going to cross that one out too, 5.3 meters to the left. of where we started, of where. Now we can say it since we've referenced the particle of where it started. Does that feel like a more natural way to word this answer to you? Now, because it wasn't really specified, like we're right that it's at -10/3, and I can see that here, but this makes so much more sense in the context of the problem. Because I want to know how did I move, which we'll get to the distinctions between displacement and stuff again when we get integral stuff. This feels like the way a human being would actually speak, though. Okay. Thoughts? Feels good? Feels bad? You want to cry? You want to high five me? Okay. Well, we got a lot of time here. Do we want to do another one like this, or do we want to practice ones like this for your assignment? Let's practice. So for now and conceivably the next few minutes, we'll take a quick brain break if you guys would like. I have no issue if you'd say, no, Holloway, I don't want a brain break. I just want to do this so I don't have homework over the weekend. I totally get it. Although alternatively, you might think, no, I don't want a brain break because I don't want to have homework over the weekend because I want to go to chess club in Mr. Holloway's classroom from 3:30 to 5 p.m. today. Might be the other way you say it. Cool. Machine Gun Holloway. Sweet. Ooh, yesterday we did practice with differential equations, so I'll put that on there. 1:30, that is today. We did apply, and this I guess is 4.8.4. Apply DiffEq. And your homework this evening, I'll zoom way in on this. Your homework you will find waiting for you. It's 4.8.2 on page 371. And I want you guys to do 37 through 51 odd. And then did we talk about any additional things you want to add to the homeworks? Yep. Start adding the due date. Did I tell you why or no? Okay. And I'm pretty sure this is the second that it's due, but let me double check that. Cool. It's due on Groundhog's Day. What? Isn't the second Groundhog Day? I don't know. I'll text Buxatoni. Tawny. Dang it. Yeah, old Philip. Crazy guy. All right. I'm not going to quite end the video in case there's one that we all agree is awful that you need a little push on. So if you're on the road traveling, I would hold off before you just end. I guess you'd see the video's not over. So what am I talking about? Do it to it.